Okay, so a lot of you might have wondered while learning logarithms about the value of, let's say, log to the base 10 minus 1. In your schools, you might have been taught that log cannot accept negative arguments, and that is true if we are not considering the only if we ignore the complex plane. The complex plane is basically a plane containing all possible numbers, so to say, that is real numbers and imaginary numbers. The best way to define imaginary number is to visualize it as being the nth root of a negative real number. For example, I is the square root of -1. Now, those of you who are familiar with basic complex number mathematics probably are aware of this formula: e to the power I theta is equal to cos theta plus I sin theta. So, using the knowledge of logarithms and Euler's famous identity, which you can derive from the aforementioned formula e to the power I pi plus 1 equals to 0, we can actually evaluate the value of log to any base to the power -1. So let's begin. We have, let's say, ln, which is basically natural log to the base 2 of -1, and let's take it as x. Now we know that from Euler's identity, which I wrote in the previous page, we have -1 as equal to e to the power I pi. So you can write this as e to the power I pi is equal to x. If you know basic logarithms, you know that this power or the argument will go outside the this bracket. So we have I pi is into ln e equals to x. Ln e is basically 1, so we have x is equal to I pi. Therefore, the value of ln -1 is equal to I pi. There you have it.